Hi, everyone. As he said, I'm Paul Ganssle. I'm a software developer at Bloomberg. And today I'm going to talk about time zones. So this talk is going to be just sort of a deep dive into the way that Python handles time zones with examples using both pytz and dateutil. So this talk came about because fairly recently, after right around Python 3.6, I had to significantly rework how time zones work in dateutil with regards to ambiguous and imaginary datetimes. So I thought I might be able to share some of that seemingly useless knowledge with people to, so that they get a better handle on it. All right, so that we're all on the same page, I thought I would just define some basic time zone concepts. So the first one is UTC. UTC is Coordinated Universal Time. It's the primary standard by which you would define all other time zones. So any kind of local time is defined as a function of its local time and, or the datetime and as an offset of UTC. Why is it called UTC and not CUT? That's because when they were first coming up with it, the English speakers wanted it to be called CUT, Coordinated Universal Time, and the French speakers wanted it to be called Temps Universel Coordonné. And so they compromised on something that makes no sense to anyone. So sometimes you'll also see it called Greenwich Mean Time. Interestingly, it's not always the same time as the time in Greenwich because of Greenwich has daylight saving time. But that's just because those two are roughly equivalent. Greenwich Mean Time is the old standard. So then the next concept is time zones versus offsets. So UTC minus 6, that's an offset. It always means 6 hours behind UTC. Sorry, this is being a little weird. All right, well, I don't know why all my slides are. Oh, there we go. All right, so it always means 6 hours behind UTC. By contrast, US Central, that represents the central time zone. So the central time zone is sometimes UTC minus 6, sometimes it's UTC minus 5. And it's essentially the rules for which offset is applied at what times for anyone who's following the central time zone. So that's most things in, say, Indiana, but not all places in Indiana, because some places in Indiana use their own time zone that is UTC minus 6 year-round. So what is CST? Is that a time zone? Is that an offset? If you're being particularly precise, you could maybe call it an offset because it's UTC minus 6, it's Central Standard Time. But a lot of people use it to mean Central Time in general. And it's also very context dependent in other ways, like the fact that CST also stands for Cuba Standard Time and China Standard Time. So just in general, these three-letter abbreviations, they're everywhere, but they will not uniquely map to a single time zone. So you should be very cautious in using them. They're really for display purposes only. They're not a useful way to get a time zone. So, all right, now this is probably everybody's favorite part, where I go through all the crazy things that people get up to with their time zones. So we'll start off slow with these non-integer offsets. You've probably heard about these. So there are places in Australia where you have, offsets that are a half an hour off from UTC, or some multiple thereof. You have some that are 15 minutes, like in Kathmandu, and then, but just in general, I would say if you're dealing with time zones, I would avoid making any assumptions about what the offset can be, right? Because there are some things that aren't even an integer number of minutes away from UTC, at least if you're taking into account historical zones. So before 1979, Liberia was on a time zone that was 44 minutes and 30 seconds ahead of UTC. Here's another crazy example. So in 1992, Portugal decided that they wanted to switch their base offset from UTC plus 0, Western European time zone, and then to the Central European time, which is UTC plus 1. And I think they felt that the way that would be least disruptive would be when they finished their daylight savings time of Western European summertime, they would just switch daylight savings time off without a corresponding offset. So you may have a situation when you're going in your code where daylight saving time and the time zone name will change, but the offset won't change at all. As a historical note, in 1996, when Portugal realized that their base offset shift was leading to sunsets that would finish after midnight occasionally, they switched back and they did the same thing. So there's 2 daylight saving time changes without offset. Another complicated time zone here is, you might think that, all right, if anyone has daylight saving time, they probably only transition twice a year, right? Once in and once out. But there are some zones where there's more than 1 daylight saving time transition per year. So since 2012, Morocco has undergone 2 daylight saving time transitions. One in, say like the end of April, and then a couple months later, at the end of July, they'll go back to standard time for 1 month, and then they go back onto daylight saving time for a couple months. So you might be asking yourself, why would they do this? Well, Morocco is a primarily Muslim country, and the month of Ramadan, Muslims are not allowed to eat until it's sunset. So they would prefer an earlier sunset. So during Ramadan, they just turn off daylight saving time for 1 month. This has happened in other countries, but notably, like in Egypt, they did it in 2010 and 2014, but not other years. And Egypt does not usually give a huge amount of notice on this. So sometimes you'll find that it's about a week before daylight saving time is supposed to start, and they'll say, actually, we're not doing daylight saving time at all this year. So keep your time zone database up to date, and don't make any assumptions about how many transitions per year there might be. So here's another interesting example. So sometimes there are missing days in a given zone. So Christmas Island in 1995 decided that they wanted to be on the other side of the international date line from where they were. So they just switched over their zone and shifted their zone by 24 hours. So right after midnight January 1st came midnight on January 3rd. So in 1995 on Christmas Island, there was no January 2nd. And maybe you're saying, well, that was the 90s. People were watching a lot of Seinfeld and skipping calendar days. That couldn't happen to me now, could it? But in 2011, Samoa did the same thing. Of course, there's also the opposite. There's double days. These haven't happened in quite a while, so it might have been the effect of bell-bottoms or something. But the Kwajalein Atoll in 1969, they decided to go the other way. And so there were 2 September 30ths in that zone. So now I've given you some examples about all the crazy time zones there are and why it's complicated. So you might be asking yourself, why do we need time zones at all? Why can't we just switch to UTC and not worry about this thing at all? So the reason for that is that humans kind of like time to work how they expect it to. Sun rises in the morning and it sets at the end of the day. And just various things about the way we handle time are nice as long as you don't have to go between zones. So here's an example of a human-centered time measure that is very useful if you're working with time zones. So if I want to know when the market, like the stock market closes in New York on a given day, I can generate this rule that says it's 5 o'clock on a weekday. That's market close. And all I have to do is go through, generate these dates, and attach a New York City time zone, and I get the correct time and offset. If I want to do that in UTC, what do, right? There's sometimes it's 10 o'clock, sometimes it's 9 o'clock. I don't really know what the answer is. The answer is that you have to have some sort of mapping between UTC and your local time, and that's what these time zone objects are. So now I'll go into how time zone Python handles their time zones. So the main mechanism for handling time zones, or I guess the mechanism, is with the TZInfo class. So if you're going to instantiate a time zone, what you need to do first is subclass TZInfo. And the reason you have to do that is because it's not a simple static offset. What it is that you get these variables, the name of the time zone, the UTC offset, the daylight saving time offset, as a function of the date and time, right? So you have one time zone object, you feed it a date time. If the date time is in standard time, it gives you one answer. If it's in daylight saving time, it gives you a different answer. So I've written up a quick example TZInfo implementation. This is Eastern time. So here is the meat of the function is daylight. And essentially this is just saying, all right, here for any given year, those are the daylight saving times transitions for the US. And then the rest of these I say, all right, if that is true, give me UTC -4, daylight saving time 1, and Eastern daylight time. And you can see if I attach it here, I get the right answer. But now what happens if I try and generate a date that is, say, 1:30 Eastern time on November 5th, 2017. So that is, there's actually two of those. There's 1:30 on the Eastern side and 1:30 on the, or the standard time side and 1:30 on the daylight time side. So it handles the first one just fine. But when I go to the second one, what happened there? I jumped ahead. That's an example of an ambiguous time. So ambiguous times are when a wall time occurs twice. So this happens during a daylight saving time to standard time transition, but it can happen at other times as well. And here's just an example of some ambiguous times, right? Now I've represented two different times that are both 1:30, and they're differentiated just by their offset. So how does this work? Up until Python 3.6, there was no official way to handle this. If you wrote a TZInfo implementation and you used the Pythonic interface, the answer was you just can't represent ambiguous times. It's not possible. So that's why PEP495 was put into place. It came about in Python 3.6, and it introduces the fold attribute of DateTime. And it also implements some changes to how time zone aware datetimes are compared. So in this model, whether you're whatever side of the fold you're on is actually a property of the date time. So you leave the TZInfo and it checks what the fold is and gives you a value based on that. So what you would do is you set fold equals 1. That's in the second instance of the ambiguous date time. Fold equals 0 or nothing is on the first instance. So now I'm going to talk about how it's changed the time zone aware date times, which so I'm going to tell you also how it was before. So in Python, when you make comparisons between time zone aware date times, if they're in the same zone, which is defined as dt1.tzinfo is dt2.tzinfo, then the wall clock times are used. So whatever the wall clock time is, if those are the same, no matter what the associated offset is, that value is true, and if they're different, it's false. So here you can see an example. When it's not an ambiguous time, it makes sense. When it is an ambiguous time, it's a little funky because you can see that these two things are actually different times in absolute time, but their wall clocks are the same. So that's just how it's defined. Equality in the same zone is equality by the wall clock. If they're different zones, then if both date times are ambiguous, then essentially what it does is it converts them both to UTC and compares them. And if they're the exact same absolute time, then they are equal, otherwise not. So here's an example. These two things have the same wall clock time, but different offsets. They're false. These two have the same wall clock time, or different wall clock times, but they're the same absolute time, so that's true. The funky thing is, and this was added in PEP495, if either date time is an ambiguous time, even if they're the same absolute time, it always returns false. And I don't totally understand why this is, but my understanding is that it has something to do with preserving hash invariance of date times. All right, so now with this comparison stuff under our belts, I'm going to go into a curious case that came up on the dateutil issue tracker. Someone came up and they said, I created this thing. I have this date time. I attached the London time zone to it. I converted it to a timestamp. I converted it back in the London time zone. And then I also created this other one where I got a new instance of the London time zone. And when I compare x equals y, and really all I did was turn it to a timestamp and back, this should be true, but it's false. When I But when I compare x equals z, it's true. But here's the funky part. If I compare y equals z, that's also true. So apparently daytime equality is non-transitive in some way. What's going on here? So the key to this mystery comes from the fact that x is actually an imaginary time. That's a time that doesn't exist in the London time zone. So, you know, if you look here, this is during a standard to daylight saving time transition. If you go 1 hour at a time, it goes 1:30, 3:30, 4:30. So here, if I attach here, Python will let you construct an imaginary datetime just fine. It makes no check onto whether this datetime exists. You're just representing it as a structure. But you're guaranteed that if you convert from UTC or from another absolute time, you will get a datetime that exists. So you can see here, if I sort of translate it from UTC into London, I can't create that time zone that way. So why was this non-transitive? So if you look here, what happens is if you were to turn this x into UTC, it will do something, but x doesn't represent a real time, so it's a little strange what that would be. But if you make a round trip, you'll find that pretty much the definition of an imaginary datetime is that a round trip will not create the same value on a round trip to UTC or any other zone. So what y and z are, since they were timestamps that were then converted into the local time, there was an implicit conversion to UTC in between during that round trip. And so we now got two different time zones that represent the same time, but a different time from x. And here's the key. x.TZInfo is y.TZInfo. x.TZInfo is not z.TZInfo. So if you remember, x and y, they're going to be compared based on same time zone values. X is 1 o'clock, y is midnight. So those are obviously false. Now x and z, if you compare them, x has a UTC +1 offset, z has a +0 offset, so they represent the same absolute time, so they are actually the same time. And then y and z are actually both the same time zone and the same absolute time, so those are also true. They're also equal. So that's some of the kind of funkiness that happens when, I guess it's a garbage in, garbage out type situation if you're working with imaginary datetimes. All right, so how do you, okay, I forgot to set all my timers. That's fine. I have 2 timers. I did not set either of them. So when you're working with time zones, and now I'm going to talk a little bit about what you should do to work with time zones in Python. So with dateutil, you can use the standard Pythonic interface. You can just attach the time zone directly to the constructor if you have some wall time input, and that will say this is the wall time in that time zone. May or may not be imaginary. If you have a naive wall time that already exists, or you just want to represent the same wall time in a different zone, you can use the replace method. So here, I started out in Pacific, 2 p.m. Pacific. If I want 2 p.m. Eastern, I can just replace with the Eastern time zone. Now, if I want to represent the same absolute time, that is to say, shift the time and the time zone, then you use the .asTimeZone property or method of datetimes. And you can see here that shifts from 2 p.m. Pacific to 5 p.m. Eastern. So with pytz, that last bit works just as you'd expect. If you convert to Eastern time, you still get 5 p.m. But what happens if you use the replace method? You get some kind of funky nonsense, right? This is called LMT. UTC offset is 4.93 hours. What's up with that? So to explain why this is happening, you sort of have to understand what pytz's time zone model is. So pytz actually solved this ambiguous time problem before there was an official solution to it. And the way they did it was all the TZInfos that they attach are straight up static offsets. And which static offset is attached is determined by the fact that the TZInfo is attached by the time zone object itself. So it essentially caches this behavior. So what you do is you instantiate a time zone, and then you localize your date time in that time zone, and then you'll see, all right, this is the correct answer. If you do any math to them, though, since it's really just creating a time zone that always returns the same answer no matter what the date time is, and you haven't relocalized it, you'll get another funky answer. So I added 6 months to this. 6 months later, you're supposed to be in standard time, but it's still daylight time. So what you do then is you use pytz.timezone's normalized method, and that will just sort of shift things to be the right answer. So that's how pytz works. I might be sort of biased in that now that we have a solution in dateutil, you might want to go with the more Pythonic thing, but if you're already using pytz, they do the right thing if you know how to use them. So how do these libraries handle ambiguous datetimes? So both dateutil and pytz will give you the right absolute time if you're coming from an absolute time, right? So if you use .asTimeZone, both of them will correctly attach the right time zone. So dateutil will set the fold attribute to 1 if you're in the fold. PyTZ will not set the fold attribute to 1 because PyTZ predates this whole fold thing, and their model doesn't require the use of fold. Whether they should still set it, I don't know, but that's just one thing that you'll notice. Now, if you're working before Python 3.6, well, I guess I should say, maybe it's obvious, but when you want to use a dateutil zone to represent an ambiguous time, you just have to set the fold attribute to 1. But there is no fold attribute if you're working with anything before Python 3.6. So dateutil provides a TZ.enfold method that will create a DateTime object that has a fold attribute no matter what version you're using. So in Python 2.7, if you TZ.enfold a DateTime, you're setting the fold attribute to 1, and it creates this DateTime with fold private object, which just is a DateTime and reacts exactly how you would expect a DateTime with a fold attribute to work. So you can still use the PEP 495 compliant stuff even if you're before Python 3.6. You may also want to say, well, if I'm in an ambiguous time zone, I want to selectively choose whether it's daylight saving time or not. So we provide the TZ.DateTimeAmbiguous method. So you can either pass it an aware time zone or a naive time zone, and then the zone that you want to know if it's ambiguous in, and it tells you whether or not the datetime is ambiguous. So you could use this here. I just go through, and if it's an ambiguous datetime, I have it default to the daylight saving time side by setting the fold equal to whether or not it's an ambiguous datetime. That said, you don't actually have to do this, because part of the PEP is that the fold attribute is ignored for anything that is not an ambiguous datetime. So if you just set fold everywhere, then you'll get standard time if it's ambiguous, and you'll get whatever's appropriate if it's not ambiguous. So what do you do if you want that in PyTZ? Well, when you localize PyTZ, by default, what it does is it chooses to go to the standard time portion of it. If you want the daylight time portion of it, you pass, or I guess version, you pass isDST equals true to localize, and that gives you that version. And if you want to know whether it was ambiguous or not, then you pass isDST equals none, and you catch an ambiguous time error. All right, so how do they handle imaginary times? So dateutil provides a similar function that says datetime exists to tell whether or not the time zone you've constructed is an imaginary datetime. Right now, there's nothing in the library that will help you deal with that, unless all you want to do is go through a list of dates and then skip anything that is imaginary. But I've written this very short, basic function that will essentially just shift you over into the second or into the standard time or daylight time, whatever the second portion. You slide forward with this resolve imaginary. And in the next version of dateutil, I'm going to have some robust version of this, but right now it's not in there. So, but you can always just get these slides; they're online, and copy this function if you really need this functionality. So, how does PyTZ deal with it? If you localize an imaginary time zone in PyTZ, it will just construct an imaginary time zone, and then it'll set the daylight saving the offset based on whatever your isDST function is. So it's an imaginary time zone on one or either side. If you have a non-existent date and you normalize it, then depending on whether you pass isDST true or false, it will just slide back or forward one offset. So you can see here. If you want to know if a time exists, you can localize it with isDST as none and catch a non-existent time error. One thing that's interesting to note is that the way DateTime exists is implemented, it works just fine with PyTZ time zones. So you can still tell if something is imaginary just using tz.datetime exists. And it will also detect non-normalized datetimes, because non-normalized datetimes are just a sort of unusual form of an imaginary datetime in that they don't exist in that zone. It's just that they're not commonly considered to be one of the standard types of imaginary datetimes. All right, so yeah, so the now that I've kind of gone over the basics of how time zones, or I guess that's more than basic, right? Some of the details about how time zone works. I thought that I would go through some of dateutil's TZInfo implementations, because PyTZ, they give you the Olsen zones and they also give you UTC, but dateutil has a whole library or module full of different time zone implementations for the different things you would want to do. So obviously it provides UTC. TZUTC is the standard zone. That's pretty straightforward. You can also have static offsets. That's called TZ offset. You just have to give it a name and an offset. The offset can be an integer number of seconds or a time delta. The name can be none or it can be a string. And then that's just a fixed offset. That said, if that's all you need, UTC and static offsets, then after Python 3.2, the standard library implemented a time zone, like a basic time zone TZInfo implementation that does both of these things. So you can just use timezone.utc, and they also have timezone, which the arguments are reversed, but it does essentially the exact same thing. So maybe you can not have a dependency on dateutil if that's all you need. Okay, so the next time zone that's very useful in dateutil is the TZLocal function. And this basically just is a TZInfo implementation that calls Python's time OS hooks to query the OS about what it thinks the current time or the current time zone should be given the datetime. So this is tz.tzlocal. You attach it. This TZContext is just something that I wrote that changes the TZ variable on a Linux system so that you can sort of test and look at different time zones. So if I set my TZ variable to UTC, I get UTC. If I set it to PST PDT, then I get Pacific time, and when I ran this, my local time was Eastern. In Windows, you can still use the TZLocal, but there's also the TZWinLocal, which queries the Windows registry for what the current local time is. And in that sense, it's a little more useful in the sense that it has a little more information about the specific time zone, not just what's the offset at this point. And it also fixes a very strange bug in the compiler used to compile the Windows binaries for Python, which is that if you change your time zone or pretty much anything about your local time settings during the run of a program, the time hooks, the Python standard module time hooks, which TZLocal calls, won't pick that up. But TZWinLocal will pick that up. So here, I changed the time zone to Pacific time. TZLocal still says Eastern time, but TZWinLocal picks up Pacific Standard Time. That said, TZWinLocal is not without its own bugs. So I guess the answer to that one is don't develop on Windows if you can avoid it. All right, so then dateutil also provides an Olsen database zone, and these IANA zone binaries, they're what ships with Unix, and dateutil also ships its own binaries just for people on Windows who don't have a natural one. You can instantiate these tz.tz file things yourself, but it's much easier to use the GetTV because then you can just use the zone name and not the actual location. It'll pick up that I have these time zones installed in user share zone info, and then it'll instantiate one for me. So the IMA database contains historical time zone transitions. So if you give it a normal, like modern time zone, it gives you regular Eastern Daylight Time. If you give it something in the 40s, you'll find that it picks up Eastern War Time, which was an extended daylight saving time that happened during the World War II. And if you go way back, you can come back to our old friend local mean time, which was the local solar mean of whatever the zone is. If you go back far enough, that's always what you get. And so I mentioned this getTZ function. GetTZ is the most general way in dateutil to get the right zone info file or the right TZInfo file. So if you pass it nothing, it gives you local time. In this case, mine is a zone info file. If your local time is a zone info file, it'll pick that up as well. If it can't find any sort of file that's like historical time zone file to attach to your local time zone, like this if it's LMT, then if you pass it a string that is, if you pass it a string that happens to match your current local time zone, it'll pick up TZLocal. If you pass it an IANA zone, it'll pick up the correct location there. And even if you give it like a time zone string as you would pass to your local time zone, that will also create an object. And this is not when I talked about the TZ string time zone, but that's what it'll get. And there are more. If you look at the documentation, to the extent that it's any good, you can find it there. So I think, all right, so I guess we're on to my final remarks. So I think I've given a reasonable overview of how to deal with time zones and some of the concepts in time zones in Python. But some people will probably want to know, do you have any advice in general? So a lot of times what people will say is work in UTC as fast as you can. That's a reasonable bit of advice if you're dealing with absolute times. Anything in the past, logging, anything where you're storing things that happened in the past, or astronomical events, things that humans don't care about, store them in UTC, absolutely. Convert them at the last possible minute to whatever time zone a human would want to see. For events in the future, the mapping between UTC and local time zones is not stable. I mentioned this before. In Egypt, they gave very little notice. So if you imagine that we're in Egypt, and I have a meeting with, let's say Joey over there. I have a meeting with Joey on Friday next Friday at 1 o'clock. This Saturday, everything should be, I'm not planning on anything happening, right? So I just say 1 o'clock next Friday, convert to UTC, store it, I'll convert it back later. Then Sunday rolls around and the Egyptian officials are like, actually, we're gonna go on daylight saving time tonight, so you should all update your stuff. So I rush out, I update my zone info, phew, everything's great, right? Except wrong, I've stored my meeting with Joey in UTC. Now, but when I first converted it, the original mapping said that, say our meeting was 1 o'clock, but its UTC is noon, and now we've shifted the time zone by 2 or something. Now it's, if you convert it back, you're gonna get, instead of 1 o'clock, you get 2 o'clock or you get noon. I lost track of my example, but essentially the point is I'll either be an hour early or an hour late for this meeting because the mapping between UTC and local time is not stable for future dates. And then the last thing, I've heard a lot of people sort of slag on naive datetimes, like, attach a time zone as quickly as you can because that represents an exact time. So if you are doing things with absolute times where you care about how many minutes it was between two things, if you care about logging, absolutely attach a time zone. That's the right thing to do. If you care about certain things where it's not even in absolute time, but you care about the time zone, you can also easily attach a time zone there. But sometimes it's useful to have a naive datetime that is sort of unmoored from absolute time, right? It's noon, it happens at noon. It doesn't really matter what time zone it is, right? We'll say, you want to know when the sun is going to be overhead. We'll just say it's noon. That's time zone independent, and you can attach that wherever. Or you have some event that's an hour before midnight in any zone, right? That's something that you can use a naive time zone for. So it's not always bad to use naive time zones. Just, I guess, think about the abstraction that's useful for your application is my main goal there. All right, so now we're into the plugs part of the talk. My company is Bloomberg. They want me to tell you that we're hiring. We have a ton of open Python jobs. I searched for Python on careers.bloomberg.com and found over 100 openings. We've got openings in offices in New York, London, San Francisco, other places too, but these are the big interesting cities. And then these two jobs in particular are in San Francisco, working on a pretty interesting application. One is writing financial libraries. The other is scaling distributed systems. And I put the links in here, so if you go on the page, you can look at those jobs. And I was just in the office this week, because I'm usually in New York. They have a very nice office. It's a nice, slow pace. All right. And then the last plug is, I am the main maintainer of dateutil. It's a pretty slow-paced kind of project, but I learned pretty much everything I know about datetimes by just getting involved. I just started picking out issues that people were complaining about, and then I would go through and I would debug them, and I would figure out why it was one thing or the other. And eventually I became the main maintainer of this library, mostly because other people don't really care to do it that much. So I've picked out a couple of things that are low to medium difficulty, these issues. So these are links. If you go on the website, you can click on them, and maybe you're interested in picking up some of these. You can hit me up on GitHub or Twitter, and my email is on here too. So if you need any help getting started, feel free to email me or just come up to me at any time in the conference. I'd be happy to talk to you about any kind of dates and times or other things too. I'm a regular human. So, all right, so that's my talk. Any questions? Oh, sorry. You guys want to clap?
So at Bloomberg, I imagine you have recurring batch jobs of some sort. You use something to trigger them, like cron or something like that. And what effect does all of the time zone stuff have on that? Like in the old days, you just wouldn't have cron jobs that run between 1 and 3 because you don't know what's going to happen. But like what do you guys, or between 1 and 2? What do you guys do?
See, I'm actually like a quant, so I pretty much, everything I do is way behind the scenes. I was doing this dateutil stuff before I went to Bloomberg, so I don't really know too much what they do in terms of time zones for cron jobs. I mean, yeah, I would guess that people try and avoid it or just hope that it's not a big deal. I'm probably giving short shrift to the people who actually maintain that infrastructure, but I'm just guessing because that's what I would have done until I, learned about this, and most of the time it's fine, I guess. Or they work in UTC, I suppose. All right, so you have a question?
I was going to say that we worked in the financial. We had this problem, and so our solution was to avoid that time or make sure your jobs, if your item code could run twice, then you wouldn't worry about it. But you did have to think about those two things. Mostly avoid it if you can, was the way we dealt with it as well. Yeah, I mean, that's probably the safest thing to do. I mean, specifically with cron, or do something that would handle it, right? But with cron and its legacy, you just couldn't trust it.
Yeah. Right. Yeah, we have one here. Oh, okay. That's fine too.
Hey, so I learned something new, which is dateutil at a TZ module. So is that directly replaceable with the pytz? Is it like it has the same stuff?
No, I mean, all those things that I went into, like all the stuff that was dateutil uses the Python style time zones. PyTZ uses PyTZ style time zones with the localized stuff. So all that localized, normalized stuff, that's all PyTZ. Dateutil, you can just follow essentially what it says in the Python standard documentation about how to deal with time zones, with the exception that they don't really talk about ambiguous times that much. So there's some stuff in there. There's subtle differences. Dateutil is a little more, Pythonic, I suppose, but I don't want to talk bad about PyTZ because for the first 14 years of dateutil's existence, PyTZ was the only ones doing it right. And then I came along because I'm a DateTime rock star. All right, so we had a question up here, Donna.
So I'm kind of curious, what do you do about leap second?
Leap seconds happen at a level of abstraction that's below Python. So Python just doesn't acknowledge the existence of or care about leap seconds, as far as I know. So my understanding is that Bloomberg, I don't really know that many of the details, but most companies, they do some sort of smoothing where they smooth out the leap seconds or something like that. I mean, leap seconds are a whole other thing, and I have a whole rant about how leap seconds should not be part of civil time, but
They held the vote, was it a year and a half ago, and they voted
to retain them, yeah. Yeah, I don't know how that happened. All right, any other questions?
But it's tied to UTC.
Yeah,
What UTC does ends up happening.
right. Everything is an offset from UTC, so if UTC has a leap second, then it's implicit, It'd be nice if we could say, let's use TAI or something, but who cares about that, right? All right, so we had a question back here.
I'm just curious what the procedure is when Egypt decides we want to go on daylight savings time tomorrow. How does that get pushed out around the world so that everybody knows that?
Well, so generally, what happens is if there's any sort of news, there's a mailing list, the TZ mailing list, that people will email in sort of references and stuff like that, and then the Paul Eggert maintains the list, and he will push out fixes. Generally, I think the attitude is somewhat, poor planning on your part does not constitute an emergency on mine. But that said, they do kind of rush it out as quickly as possible. But you're just going to be wrong. Stuff is going to be wrong in your country if you don't give the time zone mailing list a little bit of notice. And there's a blog by Matt Johnson at Microsoft about this that really goes into it. I don't have the link here, but you can. I'm sure you can find it if you search for Matt Johnson time zone notice or something. And it's basically people rush to do it, but a lot of people are not going to get it, especially not on their phones. Those things have month-long lead times. Yeah. All right. So that's everything. All right. Thanks for coming to my talk.